Example 5 of the compounded interest and continuously compounded interest lab. For example 5, we have this following problem. Suppose $7,500 is deposited into an account that is compounded quarterly, n equals 4. Find the annual interest rate that is required for the account to be worth $12,000 in 5 years. So we'll notice that it is not compounded continuously anymore. And so we have the following formula for a compound interest formula. A equals P times 1 plus R over N to the NT, where A is the amount accumulated after T years, P is the principal or starting amount, R is the interest rate in decimal form, T is the time in years, and N is the number of times the account is compounded in a year. So we need to find out what we have and what we do not have and what we are looking for. So we say, suppose $75,000 is deposited into an account. So this is going to be our P, our initial amount. It's compounded quarterly, so that means that in a year it is compounded 4 times, so n equals 4, it actually gives it to you. It wants us to find the annual interest rate, so it wants us to find R, we don't know what R is, that is required for the account to be worth $12,000 in 5 years. So this is going to be our A, or our final amount, and this is going to be our T. So we have A is equal to 12,000, P is equal to 75,100. We have R, we don't know what that is, we're looking for it. N is equal to 4, and T is equal to 5. So now we're going to plug it into the formula, what we have here. So if you forgot already, here's our formula. We have A is equal to P times 1 plus R over N to the NT. So our A was 12,000. Our P was 7,500 times 1 plus our R, which we don't know, so it's just going to stay as R. Our N was 4 because it was compounded quarterly, to the NT, so our 4, and we want to do it in 5 years, so times 5. So we want to divide 12,000 by 7,500. One plus R over 4. 4 times 5 is 20. 12,000 divided by 7,500 comes out perfectly to 1.6. Now to get rid of this exponent of 20, what we can do is we take an even bigger exponent, and power to a power essentially, of 1 over 20. What this will do is when you take a power to a power, for example, you have to multiply the two, so 20 times 1 over 20 will become 1, and anything to the exponent of 1 is just itself. So this will leave the insides open to us. You have to do it on both sides. We can also write something to the power of 1 over 20 as a radical, like that. So now we have 1 plus R over 4. So we have this. We're going to try and get R alone. So we're going to subtract 1. And then we're going to multiply by 4 on each side. So we have 4 times 1.6 to the 1 over 20 minus 1 is equal to R. And once you plug that into your calculator, you'll find that R is equal to, or about equal to, 0.095114. However, we're talking about an interest rate, so we need to write this as a percentage. So R, if we take this and move it over twice, we get about 9.5%.